for those who have not set that yet, you could actually set that on your Zoom. Just go over to zoom.us and you could set that. Kasi automatic, binigyan ko na kaagad ng permission to record the session. But since you have not placed that on your account, I have to like manually click your name and then parang ina-allow ko pa isa-isa. Pero actually, allowed naman lahat. Okay, so everyone is given permission to record now. Let's continue on with the discussion. Share ko sa inyo yung screen ko, which is this. So we'll start off with this. And as I was mentioning to you, the whole process involving the Z transform basically is similar to your Laplace transform. Even the integration process, as you will see later, when we try to derive the Z transform equivalent. Okay, so basically, Z transform is a useful tool in analyzing discrete time signals and systems as a counterpart of your Laplace transform. So again, this is used to solve LCC DE, or linear constant coefficient differential equations, okay, which is actually applied for filters. So madalas ginagamit for filters. So we want to remove unwanted noise. So i-filter out natin. And to do that on a time domain, kasi yung analog signals natin are in time domain, is very difficult. Okay? So which is why we opted to do the process in a different domain. Okay? So in this case, it's called the, ang term nila is Z domain. But basically, it's almost the same. Parehas lang halos nung, oh, bakit ganito? Animation ko mali. Okay. Ayan yan. So, notice that this is the Laplace transform. Actually, sa Laplace transform, anything below 0 is considered 0. Nakuha ba? So the analysis of the Laplace transform simply changes this value from 0 to positive infinity lang siya parate. Kasi automatic now, the signal will not exist below 0. Wala daw signal na mag-exist below 0. Negative. Negative, no? Ng time t. So ibig sabihin, you can only anticipate values that are placed as input. You cannot like forecast values before your time. Okay? So ganun siya. Hindi niya ina-allow yon. So lahat ng definitely papasok before the signal, no? Papasok do sa system, will be considered at starting from time t equal to 0. So anything beyond that na time negative, hindi accepted. Which is technically true, no? Kasi bakit? When manipulation on your signal starts, it always starts at time t equal to 0, no? And then work on until the recording is finished. Diba? Tapos mamanipulate ko yung audio recording. Let's say, re-remove ko yung mga noise, re-filter out ko yung high frequencies. Diba? O yun yung concept dun. Eh. So it's always 0. So which is why under the Laplace, they made it simpler by using only positive values for your time t. Kasi there is no signal existing, no, at time equal to negative value. No? Parang ganun yung concept niya. Okay? So it's similar to that. No? So note that S there is simply a complex conjugate. Okay? Ano yan? Complex frequency domain. Complex frequency domain kasi yan. Okay? Yung S. So hence, ay, ano ba yun? Mali-mali yung aking lang. Palpak yung animation. Let me, wait. Wait lang. Bakit nag-error yung... Bakit dito yun? Alam ko, ayos yung animation. Ah, ayan, tama na doon sa mga sumunod. Okay. Let's continue. Error. Ayan. There. So given there, if the analog is sampled at the rate of 1 over your period, where period is the sampling interval to obtain your discrete, it becomes like this. That is if you replace S with alpha plus j omega. Parang ganun. Okay. So eventually, you'd end up with a complex magnitude r e raised to alpha times your period, and your angle is omega times your period, phase angle. If you want to do that into a discrete signal, whereby n pertains to your given value at any time t, the system is simply reduced to this. Okay, ito yung gagamitin natin because we're dealing with discrete signals, no? Not continuous signals. So we're dealing with discrete signals here. So we're going to transform that discrete signal into its Z transform. So ito ngayon yung lumalabas na formula sa atin for Z transform. So when we define the Z plane, basically it's a complex plane, no? For your definition of your Z transform, it's actually defined like this. So lalabas x of n, and then you multiply that with z raised to negative n. So your value for m basically starts from negative infinity to positive infinity. Thus, your x of z now represents the Z transform of your discrete signal. For a comparison to your discrete Fourier transform, pag kinumpare ko, no? This is the discrete Fourier transform. Ano naman siya, complex frequency e raised to j omega term. So lalabas, but if you look at the concept, it's actually very similar dun sa Z transform natin. No? So it's still a complex term. However, e raised to, ano tayo, no? Z raised to negative n. Sa kanya naman, e raised to j negative jn omega. Yung x of n. Okay? So, if we derive the form, anong pinakaiba lang na? Ito. Dun sa Z transform, Z raised to negative n yan. But remember, complex frequency pa rin ito, no? Yung Z na to. Tapos sa Fourier, ito naman siya. So, it's exactly the same except ito is used for Fourier. Ito. And this one is used for Z transform. Okay? So gagamitin natin yan later when we convert discrete signals. Ganyan daw yung general form yun. So summation yan, i-add mo lang lahat, no? Mga terms. Basically like that. So in generalization, if you look at the definition of your Z transform, it's defined by this. So Z there is a complex variable. So yes, no, dahil yung Z complex variable, so lumalabas, parehas na parehas siya ng puye ko. Okay, dahil yung Z ko is R e raised to negative, di ba? So if you substitute this definition here to your Z here, lalabas e raised to negative J and omega. O di ba? Pag sinubstitute ko, may R nga lang kasama. Di ba? Pag sinubstitute ko yung Z, di ba? So ano lumabas? O, di ba? Ito yung, ano yun? What is that? Yan nasa waiting room. Oh, there. You are allowed to enter. Okay. So if you look at it, ito na yung what? Discrete time Fourier transform. O di ba? Parehas na parehas. Tapos ito yung Z transform. So you could see the similarity between the two processes. So yes. So basically it's just an alternative, no, that you could use. You could actually use Laplace, you could use Z transform, you could use Fourier transform. Okay? So note that the values of Z here requires what you call a convergence, an area of convergence, basically. Or ang term niya, region of convergence from Z-plane. So meaning all values will converge within this region. So if your values of Z are not in this region, it will not converge. The solution will not converge. So basically, ganun ibig sabihin nun. Okay? So that region of convergence for your Z transform basically is seen from a unit circle. So again, this is the substitution. Sinubstitute nga lang yung definition natin ng Z. So ayan, lumabas uli yung complex frequency natin. So and as you've seen, ito na yung ito na yung ginawa ko kanina. Ayun yung discrete time Fourier, no? Transform. Di ba? Nagkaroon ka lang ng multiplying factor na R raised to negative n. Pero ito yung format ng discrete Fourier transform, di ba? Galing yan sa Z transform. Pagka sinubstitute natin yung dito pala yun, hindi ko nakita. Okay. So, this is the region of convergence. So, it's always an absolute value nung ano mo, x of n times R raised to negative n. That's your region of convergence. It's always less than infinity. So, because the Z transform is a function of your complex variable. So hence, it's actually very easy to describe it using your complex Z-plane. Your complex Z-plane can be evaluated by drawing the complex Z-plane with poles and zeros. So poles basically means your numerate, tama. Oh, ano pala yun? Sorry. Numerator yung zeros. Poles yung denominator. So, yung numerator mo are the ones that will make your value zeros. Kaya ang tawag zeros. Pag sinubstitute mo. Yung poles are the ones that will give you infinite values. Which is why they're regarded as poles. So, pag minamarkahan sila on your region of convergence, your complex value will be reduced to like this, and your unit circle would be like this. So may unit circle ka, anything inside the unit circle will converge. Tapos, yung mga values of your poles and zeros are actually seen on this unit circle. So take note, kapag zeros, these are values substituted to your variable z that will make your function zero. Kaya tawag zeros. So when you mark them, they're marked as circles. So zeros kasi yun. Tapos lahat naman ng poles makes your value of your z infinite. Hence, ano naman siya, x ang nilalagay na mark on your unit circle. Okay, and from there, you could actually see the filtering process of your designed filter using these poles and zeros. Okay. Uh, Ideally speaking, when you create a filter, parang ganito no? Ideally speaking, gusto ko pag nag-filter out ako, totally mafi-filter lahat. As in, for example, I want a, let's say, pag naglagay ako ng signal, I only want yung signal from here all the way to here, this frequency. The usual filtering, ideal filtering would be, of course, you'd end up with, ipapasok niya itong signal dito. Pagdating dito, totally cut off. Tapos ito na. But ang nangyayari is, ideally, the signal is then tapered, which meant hindi ka agad ganyan. No? Tapos hindi ka agad nagsisiro. Nag-a-approach to zero. Yun yung mga zeros point. Tapos ito naman yung, itong point na to, ito yung pole. Ako ba? Nasundan? So you want to make that pole as thin as possible, and you want to make the zeros approach as early as possible to zeros. Kaso nga lang, hindi mo, you cannot do that ideally. So hence, it simply is tapered down. Ganyan ang nangyayari. Yung sa blue, that's the ideal condition. No? Whenever you do filter. Okay? That's the real condition pala. That's the realistic condition. No? Yung ideal condition, yung red. Na kapag yung signal ko, ganito na yung frequency, o lahat ng frequency cut off na. Wala na. Hindi na i-allow ng aking filter. Kaso nga lang, that's not what usually happens. No? Kasi if you do look at the ano nung filter circuit mo, ano lang naman ang laman ng filter circuit mo, capacitor tsaka inductor. Okay? Yun. Okay, so which is why if you look at it, the process, ano siya talaga? Exponential, no? Bumabagsak. Okay? Exponential talaga. Decreasing or increasing. Okay? So, that's how you place them. Kaso nga lang dito, tinitingnan mo sa unit circle. So, normally, you mark them as zeros, zeros, zeros. Okay lang kahit lumampas. No? That's good. Okay lang kahit wala doon sa loob ng circle. Basta, alam mo kung nasa nagsisiro yung mga values. Then, in some cases, yung mga poles, okay lang din, nasa loob siya ng circle, okay lang din wala sa loob. Basta alam mo yung part na infinite yung value nung signal. Nako ba? Okay? So, yun yun. Ano? Kasi basically, pag inano mo ito, technically, hindi naman nag-ano to eh. Hindi sila nagdidikit. Okay? Basically, that's what we've learned. No? From tangent, yung mga tangent signals, yung mga cotangent signals, hindi nagdidikit. Puro sa atin sa trigo, no? When we plot that. Okay? O yun. Basically like that. And then more specifically, if you go around the unit circle, you will notice that at z equal to 1, your omega would be 0. Ito yung angle. Eh, no? If z is equal to negative j, it becomes pi over 2, yung omega. If z is equal to negative 1, your omega becomes pi. And basically, umiikot lang siya kasi unit circle yun eh. Di ba? Nakuha ba? So, if you look at the process, ano, ito yung z value ko sa table ko. And the value here, basically, ito yung value ng 1. Diba? Anong angle dyan? 0. Diba? Dito sa point na to. Kapag ka yung z ko negative j, j to, positive j pala to, ano yung angle ko? 90 or pi over 2. Diba? 90 degrees. Kapag ka yung, andito yung ano mo, negative 1, yung z mo, diba? Ano angle mo? 180 or pi. Diba? So base kasi bumabalik lang yun eh, paikot-ikot lang eh, unit circle, and your omega is simply an angle. Okay? So within the region of convergence, usually from ano lang siya, 0 all the way to pi. Okay? Normally. Okay? For a discrete time Fourier. Okay? And for a discrete time Fourier naman, which we will see later naman siya, okay, you will see that the signal exists if the signal is within the unit circle, okay, and within your region of convergence, of course. Ganun naman siya. So many of the signals that are interesting to basically converted into Z transform are normally rational functions of Z, like this. So this is the form. So whenever you do process that signal, again, this should be a linear time invariant signals that you have pag pinaprocess natin. Okay? So when we eventually store the factored polynomial, kasi yung mga forms daw ng Z transform, madalas ganun, may numerator, may denominator. Tapos syempre ang mga variable mo dun Z. Okay? So it follows that basically there is a constant term tapos ano yun, sum. Okay? So ibig lang sabihin nito, yung values ng Z are multiplied together. So parang ano yan, Z minus 1 times Z negative 2 times Z plus 3. Ako ba? Tapos ang denominator niya, may factor uli ng Z. Okay? So yun yung A tsaka B na nasa baba. So ganun siya, no? Ano rin to? Product terms. So meron ka naman dito Z plus 1, for example, Z plus 3. Ano, Z plus 4, for example, lagyan natin para magkaiba. Para hindi mag-cancel. Okay? Oops. Puro lahat. Ito lang tinatanggal ko eh. Parang ganyan eh, no? So continuous product siya. And remember, if I equate this to 0, these are the values of Z that will make my value 0. Diba? Kasi if this is 0, any value i-divide ko by 0, 0 divided by any value is still 0. Ngayon kapag ito namang nasa baba naging 0, pagka itong baba na ito naging 0, so ito pag naging negative 1 plus 1, 0 na yan, di ba? O paano na yan? Multiply ko lahat yan, magiging 0 lahat yan, di ba? Ang tawag naman doon, poles. Okay? So yun yung concept niya ng poles and zeros. So usually, pag naka-Z transform daw, it's often written as a polynomial of Z. May polynomial of Z ka sa numerator, may polynomial of Z variable ka on your denominator. Okay? So basically like that. No? So ito yung concept nun sinabi ko. Yung alpha tsaka yung beta. Beta and alpha ang tawag niya. No? So basically A and B yun. Yung kanina. Ayan, no? Okay? So ayun yun. Ito yung beta. Ito yung alpha. Ayan. So these are all polynomials of Z. Ang sinasabi niya. Okay? So yun yung ibig sabihin lang nun ha. Pag nakakita raw kayo ng Z transform, madalas ganun. Polynomials. Okay? Parang ano? Parang Laplace transform. Polynomial of S naman yung Laplace transform. Di ba? Oh, di ba sa Laplace transform, meron kang, you could see there on the Laplace transform, just to show you the equivalence of the two techniques. Lalabas S minus A all over. Di ba? S plus A times, S squared. Ganun, polynomial ng S. Plus B. O yun, ganun, no? Di ba? Polynomial of S yan, di ba? So, ganun din yung, ito naman Z, puro Z ang variable niya. Ganon din yung Z-transform. Kasi pare-parehas, they are all the same technique. Okay? They're all similar techniques. And the concept is to make your linear differential equation easier to evaluate. Kasi if they are on a different domain, all you have to do is to algebraically manipulate them. Yun yung kinaganda doon. No? Ayan. So ito yung sinabi ko. These are basically poles and zeros which coincides with your unit circle and are represented as X and O. So, yung location ng pole is X at yung location ng zeros is represented as circles, no? On your Z-plane. So, it's technically referred to as the annulus, no? Ang term doon, annulus. Yung absolute C must always be, ang term nila, in between alpha and your beta. Para nandun yung region of convergence mo. So, alpha are those that makes your values zeros, and beta are those the ones that makes your values infinite. Okay? So, for a rational Z-transform, the region of convergence will always contain only zeros, walang poles. No? Kapag rational yung form ng Z-transform. So, listed below are some of the properties of your region of convergence. Number one, it has a finite length sequence Z-transform. The region of convergence will always include Z-plane, possibly zero, and infinity. Okay? The point Z equal to infinite is usually included if the sequence starts at xn equal to 0 for n greater than 0. So, meron tayong mga signal na xn, di ba? Okay? Let me recall. No? Recall ko sa inyo. May signal tayo na xn. Ano itsura ng signal? Discrete signal yun, di ba? So, for example, I have 1, 3, 4. Ito yung mga discrete signals ko. No? Ngayon, kapag ka-finite daw yung length niyan, limited yung elements. Okay? 0, for example. Ayan. So, ano to? This is at n equal to 0. Kasi pag nandyan yung arrow ko, di ba ganun yung finite signal? We've learned that process. No? Pagka nandyan yung arrow, or naka-underline yan, this is the value at n equal to 0. This is the value at n equal to 1. So lumalabas dyan, n is always greater than 0. Ito pala. No? So yung z equal to 0 included if xn. So yung region of convergence daw will either include these terms. Okay? Depende if your sequence it starts off with n equal to 0, tapos lahat ng values nun greater than 0. O ba? Kapag ka less than 0, kagaya nito, kasi yung n ko ng negative 1, meron bang n na negative 1? Wala, sir. Meron bang n na negative 2? Wala, sir. Kasi nag-start ako n equal to 0 eh. Ayun. So, ano yun? Ang value ng xn is 0. Kapag ka less than, no? Yung n. Di ba? So, ano mangyari? Your z equal to infinity is included. Included siya. Okay? Kapag ka naman daw, yung z mo is 0 for all values greater than n, then z equal to 0 will be included in your region of convergence. O paano yun? Kung yung z mo naman, okay, puro ganito. O ano to, no? N less than 0. Okay? Ito yung xn ko. Okay? Tapos nakalagay sa xn mo, nandito yung ano, 0, then I'd have, ito yung arrow ko, no? 0, then meron akong 5, meron akong 3, meron akong 2, meron akong 1. So automatically, this is what? X at, this is n at 0, sorry, hindi x. N. So ano nangyari? Any value above n greater than 0, ang value niya puro 0. Tapos nagkaroon ka lang ng value what? At negative values of n. So ito yung n at negative 1. Okay? Mali yung sulat ni sir. Okay. N equal to negative 1. Ito yung n equal to negative 2. Nakuha ba? And so on and so forth. Which is ito yan, ano? Lahat ng n greater than 0 is 0 ang value. So ano mangyari? Yung point mong z equal to 0 is included as a region of convergence. It's important to know the region of convergence, no? Because later on, we will be needing that to identify your discrete signals. Okay? Yun siya. Okay? So, ganito mangyayari niyan. So, always, ang possible region of convergence, tatlo lang. Okay? When you're doing Z-transform. That is, if you either form a ring like this, okay? Or, ano yan no? Ito yung region of convergence ko. Ito yung unit circle. It's either lahat ng nasa loob, yun yung region of convergence mo, or lahat ng nasa labas, yung region of convergence mo. Ganun ba? Nakuha ba yun? Or yung special type which is nagiging ring. Okay? May region of convergence ka, tapos may limit. Okay? So, pag nagkaroon ng limit, yung region of convergence, magkakaroon ka ng dalawang circle. Okay? Tapos, nandito lang yung region of convergence mo sa loob niyan. Which is basically like a special nung first two. Okay? Yun yung region of convergence. Pero nauna kasi dito sa PowerPoint ko, nauna siya. So, ito yung ring, region of convergence. No? The other, yung right-sided sequence of the Z-transform, the region of convergence is the exterior of your circle. Basically, ganyan. Ayan siya. Okay? So, lahat ng nasa labas ngayon. No? And then, of course, the other one is the left-handed sequence, which meant that the Z-transform will include the interior of your circle. Ito naman. Okay? So, yung ring basically is a combination ng dalawa. Okay? Nagkakaroon ka ng limit sa left, nagkakaroon ka ng limit sa right. So, eto na yung equivalent transforms. I've given it already. So, you don't need to basically solve for those Z transforms. Nako ba? And ano yung importance ng region of convergence? It differentiates your signal. No? Kasi if you look at the Z transform table, pag tinignan mo, sir, itong Z transform nito, ito siya. Okay, alam ko na, walang problema. But if you look at this signal, pareho sila nung Z-transform. Ayan, no? O di ba? Malilito ka ngayon. Di ba? Kasi pareho sila ng Z-transform. But if you look at the region of convergence, magkaiba sila ng region of convergence. Nakuha ba? When you evaluate them. Nakuha? Okay, in any case, I've included here the derivation ito. Itong Z-transforms na to. Just so you could you don't need to derive them. So, ito yung table. This is the table that you'll be using. And I'll even show you how to use this table later. No? So, this table would be very helpful, especially when dealing with discrete signals, having a value, no? Pattern value. So makikita nyo dyan. Okay? So meaning, if I have like a signal that is a constant, then basically when you create the Z transform, it is simply in the form of uh, coefficient times z raised to -1, -2, -3, etc. etc. Wait lang. Okay, so we'll show the derivation of these terms, no? That way you would know. Take note, this is the same signal, negative lang nung AN, alpha N, so negative lang siya. Okay, tapos ano nangyari doon sa signal natin? It was flipped and then shifted to -1. O, di ba? Na-flip siya, tapos sinif siya. So, ano yung Z transform? Ganon. Okay? So, parehas lang daw ang Z transform. Okay? But, do you have a different region of convergence? So, pakita natin. That way you'd know how this was basically derived. So, there are eventually two techniques when applying Z transform. Okay? One is if the signal x of n is discrete and finite, limited daw yung signal, okay, uh, in this given form, wait lang class. Okay, so it's given on this form, tapos limited daw siya, that the transform is basically direct. Okay? So when you do direct transform, siguro maganda magbigay tayo example. No? Paano ko directly na-apply yung Z-transform, sir? Pretty much like, for example, meron kang x of n limited, finite siya. As nandito yung zero ko. Okay? Ayan, n equal to 0 ko. Ano lang, ito lang daw, x of n, which is this value, ito yung x of n value mo, no? Take note, this is your x of n value. Tapos, z raised to. So, ano lalabas yan? Ano yung z transform nito, sir? Ang z transform niyan would simply be 0 times, kasi 0 yung value nun, z raised to 0. Eh, any value raised to 0 is simply 1, so magiging 0 lang yan. So, parang baliwala, no? Okay. So, wala naman palang kwenta yung first term. So, tatanggalin ko na lang, di ba? Kasi 0 raised to times 1 is simply 0, di ba? So, tanggalin ko yung first term. So, wala na yung first term. Sumunod, paano yung second term? Eh, 1 yun. So, magiging 1 times z raised to negative 1. Nakuha ba? Or basically, parang z raised to negative 1 lang. Kasi 1 yun eh, di ba? 1 yung coefficient. O z raised to negative 1 lang yan, lalabas. Plus, ano yung next term? 3. So, ano yun? 3z raised to negative 2. Bakit negative, sir? Eh, kasi negative n. So, pinasubstitute ko lang yung n value. Eh, dito, n is 1. Dito, n is 2. Diba? So, pag sinubstitute ko, lalabas talaga negative 2. Kasi negative n ang nakalagay sa format. Nakuha ba? So, pag kinuha ko yung z-transform lahat niyan, yung discrete time na to na limited talaga, direct yung z-transformation ko. Parang ganito lang, no? O, lalabas. Ano yung 1? Pag transform ko yan. So, lalabas. 1 times z raised to negative 3. Or kahit z raised to negative 3 na lang, ano? Plus 5z raised to negative 4. Di ba? Ganun lang. Direct na yan. That's what you call direct z-transform. Nakuha ba? Okay, so literally, I have discrete signals here, and I could directly convert them into z-transform just by using what? This format. Ito yung format natin. No? Again, no, that would be meaning if that is limited. No? Kapag hindi limited yun, sir, ang daming term, then hindi. Paano, sir, kung may pattern yung term? Oh, therefore, magiging infinite yung terms din. Di ba? Kasi infinite yung sequence na yan. Okay? So, paano kung infinite na yung sequence? Then you use the table. Saka mo gagamitin yung table. No? Okay. So, nakuha yung direct method. No? So, basically, that's how, ganun lang kadali, no? Mag-transform ng z. So, where z is basically the complex variable, the relation of sometimes called direct z transform because it transforms the time domain signal, which is your x of n, into its complex representation z of n. So, basically, you also likewise do that on the inverse z. Kasi pag nag-inverse z ka, naalala ba yung Laplace transform? Di ba may inverse Laplace? When we try to make the signal and change it back to the time domain, gagamit tayo ng inverse Laplace. So dito, pag nag-change natin sa z transform, gagamitin natin inverse z transform. Nakuha ba? Parehong-pareho ng Laplace. Literally, no? It's exactly the same process as your Laplace. So which is why the table that we have is also the one we will use to change back your signal into your discrete signal domain. Okay? So yun uli yun. So let's see. Ito yung sinabi ko, no? May example pala ako rito. Okay. Nagpakapagod pa si sir. May example pala doon. Okay, ayan. Ito yung first discrete signals natin. So, ano yung conversion natin? Ayan. Okay. When you convert them to Z. Okay. Ano nga yung region of convergence na? It's the entire Z-plane except 0. Nakuha ba? Bakit? All values less than 0, nung n natin, wala. 0 eh. Nakita ba? So only values of n greater than 0 are seen on your signal. Therefore, the region of convergence is the entire Z-plane parate. Except 0. Nakuha ba? So lahat yun except 0, yun yung buong ano mo, region of convergence. Okay? Eh, paano to, sir? Ayan. Yung 5 ko, that is where n is equal to 0. Okay? Ayan, paano yan? Nasa gitna, no? Yung signal, n equal to 0, nasa gitna. So, paano naman yan? When we transform that, ganyan ang C transform. So, what would be my region of convergence? The region of convergence, again, is the entire Z-plane. This time, except 0 and infinity. Okay? Nakuha ba? So, parang ito ay ring. Kasi bawal yung 0, bawal yung infinity, bawal yung... Nakuha ba? That is if you have this discrete signals. No? Okay? And take note, direct ang transformation natin yan. Ano? Kasi lumalabas, this is at n equal to 0. So, ito siya. So, magiging 5 times z raised to 0. And z raised to 0 is simply equal to 1. Diba? Any variable raised to 0 is simply 1. So, 5 pa rin siya. So, dito naman, magiging 2 times z raised to negative of negative 1. Kasi n here is negative 1. So, magiging positive 1. So, z raised to 1 is simply z. So, 2z. Tapos dito, 1z squared. So, dito naman sa kabilang side, negative. Z equals to raised to negative 1. Z is equal to, o dito, 0 to. So, bali wala na yan. Dito na ngayon, z raised to negative 3. Nakita ba? Direct transformation. But, notice that the placement where your 0 is affects your region of convergence. Okay? Naapektuhan yung region of convergence. Ito pa. Okay? So, you have this. So again, notice puro ano lang yan, positive values of n. Pag walang ano no, walang nakalagay na arrow, automatic. Ano siya no? You always denote this is n at 0. Ayan na. Hindi na nilagyan ni sir no ng arrow. So automatic yan na 'yon. Nako ba? That is n at 0. So when you convert that and transform that, ganun ka agad no. Okay? And again, except 0 lang yan. Kasi bakit puro positive yan? All those are positive values of n lang. Okay? Tapos yung negative, wala. Hindi nag-exist. So meaning, they're assumed to be always 0. Kapag ka hindi nakabigay, it's not listed there, assumption is 0 yun, kaagad. No? It's not there. Okay? So 0 kaagad ang assumption sa kanya. So that would be the region of convergence. Here naman, again, in between, ano na naman? Z equal to 0 and Z infinity, except na hindi sila included on your region of convergence. Nakuha? Parang magkaparehas lang pala yung dalawang example na yun. Dapat pala nagbigay ako ng different example. So, paano kung ano lang, negative lang. Okay. Hindi ako nakapagbigay ng. Anyway. So, under your okay. So if you notice, no, kapag ka finite duration, it's So when you have a finite duration signals, it's always, parati ang region of convergence niya is always the entire plane. Tapos, you only need to check whether 0 is included or infinity is included within the region of convergence. O not included sila. O ba? Okay? Paano kung unit sequence? So meaning, ano yung unit sequence? Yung ano lang, parang delta function. Si 1 siya at n equal to 0 and then 0 anywhere else. Okay? So paano yung delta function? So within the delta function, ganito yung convergence niya. So for all values of z, parating 1 na siya kaagad. Okay? 1 lang siya talaga. Tapos yung region of convergence is everywhere on the plane. Lahat. Okay? Lahat ng area, region of convergence. Okay? So for example, meron akong unit step here. Okay, continuing na. Again, this is just the derivation, no? Based on the table again, no? Pinakita ko lang here. So if you have like an alpha multiplied to a particular unit step, eventually you'd end up with a sequence of signals. Again, ano to, no? Finite yung duration niya. Finite yung duration. Okay? Kaso nga lang, ano siya? Sobrang dami, no? Kasi all the values of n may be, pero exponentially ano siya, decreasing dapat to be convergent, no? Because if this signal is not exponentially convergent, like exponentially increasing, obviously it will not converge. Therefore, n there must always be alpha. Yung alpha value ko must always be a value less than 1 para mag-converge. Okay? So, ayan yun, ano? So, yung alpha ko must always be a value less than 1. Otherwise, hindi ako magko-converge. Okay? So, if you plot that, it becomes exponentially decreasing. So, parang ano yan, no? If alpha, for example, ano lang, here, anong actual value niyan, sir? No? Baka tinatanong mo. You might be, sir, anong actual value nito? Anong actual value nito? Anong actual value nito? So basically, for example, if alpha would be, let's say, point 0.1, okay? Raised to 1, it's raised to 0, it's still what? A value of 1. So any number raised to 0, di ba? Is simply equal to 1. So ito ay magiging 1 parate, no? So ano yan? Unit step 1. 1 sa 0 at n equal to 0. Paano dito, sir? Itong pangalawang value na to. Anong value dyan ng height ng aking signal? So magiging 0.1 raised to 1, which is simply 0.1. So pagdating naman dito, yung pangatlo, anong height ko dyan? 0.1 raised to 2. And if you square that, di ba? Hindi pala pwedeng 0.1 kasi tama, may liliit to, no? Magiging 0.01 to eh. 0.01. Yan, okay? Liliit yung amplitude. And so on, kaya exponentially decreasing yan, ano? You will notice. So that will always happen, okay? Based from this concept. And notice that etong value daw natin only on positive. Dito lang. Okay? Dito, beyond that, puro zero. Naku ba? Sabi rito, you have signals of a alpha raised to n only at this value. No? Tapos, kapag less than 0, 0 na siya. So, lahat yung 0. So, technically, ganyan yung lalabas na waveform sa'yo. No? Exponentially decreasing yung mga sticks mo. Okay? And remember, alpha there should always be less than 1. No? Kasi kapag ka greater than 1 yan, mag-i-increase yung exponentially increasing yan and it will never converge. Tataas ng tataas yung value eh. It will exponentially increase. Okay? Ito, magko-converge yan sa 0 kasi liliit ng liliit hanggang it approaches 0. So definitely it will converge to 0. Di ba? Okay, kung pataas ng pataas yan, it will not converge to 0. Di ba? So that's the concept there, no? So which is why that's the given condition there. So using the definition of your Z transform, eto raw. Gagawin ngayon natin dahil ang dami ng signals. There would be numerous signals. Kahit sabihin mo, sir, mako-compute naman yan eh. Kaya naman natin computein each term for n equal to 1, n equal to 2, n equal to 3. O di ba sir, finite na yon? And I could like apply the finite terms? Yes, pwede yun. Actually, pero ang dami nun, ano? I-add mo lahat yun. Di ba? Okay. O if you use the table, pag ginamit mo raw yung table, mas madali. Kasi according to the table, if your alpha n is raised to z raised to negative n, basically like this, ito na raw yung automatic Z transform niya. Okay? That's the basic transform there, no? When you have an alpha of z raised to negative 1. Okay? And technically, you could actually prove that, no, to be equal to 1. Okay? Because if you sum up all of these terms, magka-cancel out yung ibang values ng z. Okay? Meron akong, I have that concept there included on the handout. So you don't need to worry regarding that. Paano naging ganito yan, sir? No? Parang ganyan. You might be wondering, sir, paano mo nalaman na itong summation na to is basically equal to this? Okay? Nako ba? You could either do recurrence relation formula. Pwede ka mag-recurrence relation, sum up all the terms, factor out all the common terms, makikita mo, magka-cancel out yung the rest, matitira sa'yo ito. Okay? You could do that, or there's a simple sequence that you could actually show to prove that basically they are equal. Okay? Nandito ba yun? Anyway, makikita natin kung nandito sa handout yun. Okay. So, ano yung region of convergence? The region of convergence would be, of course, absolute alpha. Your Z would be always greater than your absolute alpha. So hence, your Z transform would be like this. So again, if that is your Z transform, you will notice that pagka ito yung Z transform mo, ang pole mo would be alpha equal to Z at yung zero mo would be Z equal to 0. So hence, ayun yun ano. If Z is equal to 0, yun yung 0. If Z is equal to alpha, yun yung pole kasi nagiging infinite no. So if you draw the figure now, this would be the figure. Okay? So the shaded region is that region of your convergence. So all of that would be your region of convergence. So ano mangyari niyan? So starting from 0 all the way to alpha, hindi ka magko-converge doon. Tapos from alpha going to infinity, magko-converge ka na. Okay? So that's your region of convergence. So basically, ano lumalabas? Exterior ng circle natin. Okay? Yung exterior ng ating unit circle. Okay? Yung convergence natin. Actually, hindi pa yun yung unit circle. Yung unit circle pala yun. Nasa loob pa siya ng unit circle. Mas maliit pa siya sa unit circle because it's alpha. It's not yet 1. No? Okay? So if alpha now is greater than 1, it's very similar to, again, discrete time Fourier transform nag-exist. So this example is basically called the right-handed sequence, wherein the region of convergence now is the exterior of your circle na nakita natin, and uh, this is the left-sided circle kapag yung Z transform naman ng sequence na ito. So ang ginawa niya, negative again yung alpha, and you will notice that the value exists for uh, basically n less than 0. So ito yung negative portion naman. Okay? So kapag ka negative portion, basically magkakaroon ka ng anti-causal kasi you get time scales of negative. So technically anti-causal na siya. So nagpe-predict ka ng value at yung sequence niya has to be exponentially decreasing pa rin. So hence, your alpha there should be between 0 and 1. Again, no? Yung alpha mo should be between 0 and 1. And dahil negative siya, nasa baba siya ngayon, no? Nakabaligtad. Okay? Tapos, exponentially decreasing pa rin siya. Okay? As your n increases. Okay? So, ganyan yung itsura naman ng sequence no, kapag baligtad daw. Ano yung Z-transform niyan? So, Z-transform nito will use definitive. The way, again, in the table, you end up with this. And again, notice na pareho sila nung Z-transform na lumalabas. Because if I factor this out, lalabas. Ito na naman. No? Oh, sir, ito yung Z-transform no kanina. Yung alpha raised to n, u of n, ganun siya, no? Ito ngayon, negative alpha of n, u of negative n minus 1. So, lumalabas. As it turns out, they end up with the same sequence, no, or transform, Z transform. But they ended up with different region of convergence. Nakuha ba? Kasi nasa left side na ito, nung sequence mo, of your zero axis, no? Nasa left side na siya nung zero axis mo. Then you'd end up with a different region of convergence. So basically, I've shown there na parehas lang yung transformation nila. So if we use the given table, you will see there that it's exactly similar. However, the region of convergence here, yung isa outside the circle, dito naman lahat inside the circle, yung region of convergence niya. When you use that signal, no? So, eto naman, nasa loob naman. So, alpha, lahat na nasa loob nun is the region of your convergence. Okay? So, again, if alpha is greater than or equal to 1, the circle is not included within the region of convergence. And basically, if you have a discrete time Fourier transform there, it does not exist there. So that's one advantage of your Z transform, no? Kasi yung may limit yung discrete time Fourier. So meron siya mga signals that he cannot process. Okay? Hindi niya ma-represent yung signal na to. So it's because there would not be any region of convergence there from that concept, no, nung Fourier transform. Pero ang kinaganda ng Z transform, lahat nagkakaroon ng region of convergence, no? Kahit anong signal pa siya, nagkakaroon siya ng region of convergence, which means that we can actually apply Z transform to any type of signal, kahit ano pang signal siya. Okay? So if you compare then the signals on your A and B, pareho sila, exactly the same, but they have different region of convergence. Therefore, the Z transform of the sequence is not uniquely defined. Nakuha ba? Hindi meron talagang pagkakataon na you'd end up with the same Z transform pero different signal. Okay? So, the region of convergence will help you convert your signal from a Z transform back to a discrete signal if you know the region of convergence. Okay? So, yun yung concept nun eh. So let's say we have this Z transform nito. What's the Z transform of 1/2 raised to n un? So the signal consists of infinite numbers of non-zeros again. Okay, so it becomes like this, no? So take note, only on positive n lang siya, no? Okay, hindi siya walang negative n dyan, no? Okay, so 0, then you have 1/2, then 1/2 squared, 1/2, and so on and so forth. So it has an infinite power sequence. So when we directly transform that into Z, ganyan lalabas. So it becomes, ano no, sobrang dami, hindi natin makukuha yung entire sequence. So usually you write it down as a sequence like this. Ito ngayon yung lalagay nating sequence. And note there, you could actually simplify the process, okay, by converting your function. Ito na ngayon, ito yung form natin, ano? Ito yung form natin, 1/2 n, di ba? Tapos ito ngayon, pinasok lang sa loob, I factored out your n. Okay, ganyan na. Okay, and then ito yung concept nun kung bakit naging 1 minus a yun. Okay? So ito yung concept. If I have that sequence, a plus a plus a, nakuha ba? At all values of a, technically, ang matitira lang sa akin basically is equal to 1 over a minus 1. Kasi if you look at this concept, no, and if I do multiply this, ito lang yan, no? Ganito lang yung concept dyan. As simple as this. No? If you look, if I multiply this to this, kasi babalik ko, so magiging ano lang yan, 1 plus a squared plus a, lumit yung a ko, sorry. Naging small letter. Eto. Kaya sabi ko nandyan yung solution nito. A raised to 4, etc., etc., infinite yung sequence yan. No? Plus, 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 plus. Infinite yan. Tapos, multiply ko to. I will multiply this with 1 minus a. And then, equal daw yan sa 1. So, kasi ayun yung concept, di ba? Nilipat ko lang sa kabilang side. So, look, multiply ko, so magiging what? 1 plus a squared plus a cubed plus a raised to 4. O, tapos multiply ko ng a yun. And so on and so forth. Plus, plus, plus. Multiply ko ng A. Ang lalabas? Negative A times 1. Ano lalabas? Negative A. Negative A times A. Lalabas negative A squared. Negative A times A squared. Lalabas negative A cubed. Tama? Negative A times A raised to A cube. Lalabas negative A raised to 4. Di ba? O, pag inad ko yan, dalawang yan, magka-cancel to. Ano matitira sa'yo? 1. O, di ba? Equal sa 1. O, di ba? That's the concept. Bakit? Sir, paano mo nalaman itong buong sequence na to, infinite sequence na yan, is simply equal to 1 all over 1 minus A. Di ba? It's because, ganun yun, try mo, i-multiply mo. That's the simplest, basic definition there. Kung paano ko nalaman na equal sa 1 yan. Nakuha ba? Or etong infinite sequence na to is equal to 1 all over 1 minus A. Nakuha? So yun, gawin mo lang alpha yung A, o yun na, nasolve mo na yung kanina. Diba? It's exactly the same. So, consequently, it converges to 0 if your z 1/2 multiplied by z raised to negative 1 is less than 1. So, consequently, your z would always converge to, eto ngayon yung conversion niya. Using the table, no? Okay. So, ayan ngayon yung ating z transform ng ating signal. That's the infinite signal. Ano? Tapos, ito yung region of convergence mo. This is your region of convergence. It will always be less than, kasi ano to, right-sided sequence. Okay? So, meaning, the region of convergence would be parang ganito, no? Lahat ng values of z greater than 1/2. So, ito yung 1/2. Lahat ng values dito sa labas, convergence. Diba? Ito yung 1/2. 0.5. Negative 0.5. Kasi unit, ano yun eh. Hindi pa yan 1, ano? Ito yung unit circle eh. Nakuha ba? O ganun nga yung lumalabas yan. Okay, eto naman. Paano ko makukuha yung z-transform ng dalawang signal? Okay. So again, we already know the z-transform of this. Alam na natin yung z-transform nito. Okay. Paano to? Okay. So, ganun din. Add mo lang. Z-transform nito plus z-transform nito. Ganun siya. So parang naglalaplas ka rin, no? Each term, you transform each term. And then eventually, add mo lang siya. Ganun siya. Okay? So, basically, you'd end up with, we already know this transform nito. Okay? Which is that, okay, alam na natin yan, yung transform yan. So, hanapin na lang natin itong 2 raised to n, u to n minus 1. Yan. So, yun na lang hanapin natin. So, again, from the previous example 2, given there, ayan, para dito, so it end up with, notice, no, parehas lang, 1 over, ito pa rin, pero ang region of convergence, baligtad naman. Less than 2. Okay? So ano ngayon yung region of convergence nito? Dalawa, sir, yung z mo. Yung isa greater than 1/2, yung isa less than 2. So magiging ring. Pag in-add mo ngayon, okay, ito yung z-transform ng first signal, ito yung z-transform ng second signal. You could actually simplify that further. Okay? Pwede mong i-simplify pa, giving it a common denominator like this, magkakaroon ka ng common numerator na ganito. Or leave it as it is, okay lang din, parehas lang naman yun. Okay? Pero in some textbook, they try to combine that so that they're all factors of z. Okay? So ganoon ang ginagawa. Pati yung numerator may z. Yun yun eh, no? So nagkakaroon ng z yung numerator if you simplify that. So ano yung region of convergence niyan? Dalawa. In between. Okay? So yun yung region of convergence. Kasi dalawa yung signal. So Basically, andito ba yung ano nito, drawing? Ay, wala pala. So, parang ganito lang yung drawing ng region of convergence. Meron kang 1/2 tsaka 2. It's between 1 and 2 eh. 1/2 and 2. So parang ganito, no? Meron ka ngayong unit circle. 1 yan. Ay, ang galing ng drawing ni Sir, ang pangit. Ayan, ganyan man lang, no? Para 1 lang. Ang pangit ng drawing ni Sir. Okay. J -1, 1. Ayan yung unit circle, no? So, 1/2 daw yun. So, nandito yun, no? Kalahati. Okay? So, lalabas yung 0.5. Ito yung 1/2. Tapos, nandito yung 2. 2. Nakuha ba? Nasa labas yung 2. So, in between that, that is your region of convergence. So, parang mula rito hanggang dun. Parang donut siya. Ayan. Ayan yung naging region of convergence. Kasi dalawa yung signal, eh, no? Inad natin. So, naging ganyan yung region of convergence. Okay? Kaya lumalabas dito, in between. Ayan. Greater than 1/2 but less than 2. Okay? Nandun yung region of convergence mo. Nasandan? Kasi yung isang signal left-sided, yung isang signal right-sided. Okay? So, ang naging, ano mo tuloy? Parang donut, no? Lumabas sa atin na region of convergence. We'll transform more of that and show you the derivation, so we could eventually use those functions in the table for your Z-transform next meeting. Okay? So, kindly turn on your cameras first for a few seconds so you'll be recorded within our session. Again, the Z-transform is also there on your video lesson. You could look it up. So, tingnan nyo yung video lesson din. May video lesson na akong pinabay doon for Z-transform. Just look it up there. Okay? To reinforce your learning regarding Z-transform. Okay, so thank you very much, guys, for joining in our session. Thank you, thank you. Stay safe, stay healthy.
Thank you, sir.
Yes, you may log out of the session.
Thank you, sir.
Thank you, sir.
Ingat, guys.
Thank you, sir.
Mag-ingat. Kamahawan, sakit, mag-ingat.